examples 6, 7, and 8, they are all going to be the same type of problem. They're going to give us some conic section equation. They're going to ask us to identify it as a parabola, hyperbola, or an ellipse. We're going to graph it using all the important stuff for that type of graph. So once you establish what kind it is, if it's a parabola, I want an axis of symmetry, a directrix, a focus, and a vertex in the graph. If it's an ellipse, I want 4 vertices, 2 focal points, the center, and the graph. If it's a hyperbola, I want the 2 asymptotes, the center, the vertices, and the foci, and the graph. So what we want to do is look at the characteristics of the general form to establish what kind it is, to help us establish what the standard form is supposed to look like, and that leads us to all the information we need. The first one here, 4x squared plus 9y squared, everything's equal to 0. General forms are going to be everything equals 0. So the fact that x and y are both squared, they're both positive with different coefficients, tells me it's an ellipse. So if both x and y are squared, it's either an ellipse or a hyperbola. With ellipse, we have to have the same sign, the hyperbola different signs on the x squared and y squared terms. So it's going to be an ellipse, so we're going to create the ellipse standard form here. And if I just go ahead and establish that, it's supposed to look like x minus h, the quantity squared, over a squared, plus y minus k, the quantity squared, over b squared equals 1. That's what we're looking for standard form. I want to create that standard form from the equation given to me. I'm going to do all the stuff I'm supposed to do, grouping my x's together first, grouping my y's together second, and I'm going to move the constant to the other side. So the first step in getting standard form is to get everything of the same type together where it belongs. So something about x plus something about y equals a number, something about x plus something about y equals a number. I want x squared and y squared, not numbers in front of x squared and y squared, so I'm going to take a 4 out of this one, leaving x squared minus 4x, leave some space. I'm going to take a 9 out of this one, leaving y squared minus 4y, leave some space, equals negative 16. Just factoring, it doesn't affect the right-hand side in that step. As far as completing the square is concerned, we're going to add 4 and add 4 here for both of these. Half of 4 is 2, 2 squared is 4, half of 4 is 2, 2 squared is 4. Remember, we're always adding because we're squaring. In reality, I added 4 inside of parentheses being multiplied by 4, so that's actually adding 16. And I'm adding 4 inside of parentheses being multiplied by 9, so that's actually plus 36. So altogether, if I factor everything now, I got 4 parentheses squared, x minus 2, plus 9 parentheses squared, and that's going to be y minus 2, and then 16 minus 16 is 0, plus 36 is 36. So you create your perfect square structures first, and then you want to get the over a squared over b squared equals 1 structure. So at this point, I'm going to divide by 36. So equals 1 is happening. I've got my x minus 2 squared on top, and I got my y minus 2 squared on top. I don't want numbers being multiplied by those. So 436 reciprocates to 36 fourths, also known as 9. 936 reciprocates. 36 ninths is the same as 4. If those didn't divide evenly, you're going to leave fractions on the bottom. I've seen people like do over 436 over 936. Make sure that this fraction here is what's being reciprocated, so it's 36 on top over 4, 36 over 9, so they reduce the whole numbers 9 and 4. So I got my standard form created, and again, once I got my standard form created, that establishes the center, and A and B and C allow me to find the vertices and the focal points. So I know my center in this case is 2, 2. I know A is equal to 3, B is equal to 4. The square root, B is equal to 2. A squared is 9, the square root of 9 is 3. B squared is 4, the square root of 4 is 2. And then C squared is the difference of these. So C squared is equal to 5. So C is going to be the square root of 5, which is 2.23, I think. 3, 4, 7, 9, 8, 2, something.
Yeah, it's 2.236.
There we go, 2.236, perfect. So 2.24 if we rounded it properly, so 2.24. Alright, so just like that, I've got a center of 2, 2. I'm going to go 1, 2, 3 spaces right, and 1, 2, 3 spaces left. I'm going to go 1, 2 spaces up, and 1, 2 spaces down. Those are my 4 vertices. Focal points are on the major axis. We're going left and right more than we are going up and down, so major axis horizontal, 2.24 to the right, 2.24 to the left. As far as identifying points, center is 2, 2. I got 4 vertices. I got 2 focal points. Alright, so focus on the vertices first. Okay, so 2 comma something, 2 comma something. So 2 comma something, I moved up and down. So I'm going to move up and down 2 spaces from 2. So 2 minus 2 is 0, 2 plus 2 is 4. Moving left and right, I'm modifying x from the center, and I'm modifying x by a value of 3. 2 minus 3 is negative 1, 2 plus 3 is 5. And I'm moving left and right here also, so the y-coordinate is going to stay 2. Moving 2.24 left and right. So again, if I've got my y-coordinates established as 2, I got to move 2.24 spaces left of 2. So 2 minus 2.24 is negative 0.24. 2 plus 2.24 is going to be 4.24. So again, if you want to establish what the actual coordinate values are, you just add and subtracting from x or y the values of a, b, and c. So there's the 7 points I'd want to have identified. There's all 7 points graphed, and I connect those 4 outside points with a nice elliptical shape. As pretty as I can make it using my terrible artistic ability. Might kind of make it curvy. I missed that point by a smidge, but I'll trust that you tried your best to hit those points if yours look like mine.